Okay, so I just learned something very important. This camera will only take up to 30-minute video, so I know currently this is not where the first video is going to be left off. So this is going to be a two-part video. Essentially, everything I was saying before, and I apologize for how abruptly it's going to cut out, is going to be right here. Again, I crisscrossed everything, -2 here, +1 here, -2 went here, and the +1 went here. And all I was saying in the previous video was, and again, now I know I have a stopwatch I can use, this is the only way where you're going to have a double replacement with no reaction. If you have something that is aqueous and aqueous to something that is aqueous and aqueous, again, dissolved in water, make something that is dissolved in water and dissolved in water. I'm going to really quickly get some glasses from my kitchen. I'm going to show you exactly what that looks like. And you're going to see why, well, that's not going to really help us out. And again, I'm also going to turn the lights on. I kind of want to see what the lighting looks like too, because I know it's getting a little darker and it was cloudy today. All right, that looks a little bit better. I'm going to go grab the glasses really quick. Again, my estimate is it took about 30 seconds, so if you just wanted to fast forward to there, that might work. Really quickly, just kind of wanted to show you. This is just regular old tap water. There's nothing special about it. And there's nothing really special about this one either. Now, here's the thing. A bunch of things, when put in water, are going to look like water. If I put sodium sulfate in water and dissolve it, and it's aqueous, it's gonna look like water. It's gonna be a clear solution. You're not gonna be able to tell that anything was in there, just like salt water. But you know if you taste salt water that it's there. So with this one, you know, if I say that this is, say, I'm just gonna grab the black one really quick. If I say this is like sodium sulfate, if I say that that is sodium sulfate, and I apologize if the camera's not picking it up well, because of how it's zoomed, I apologize if that didn't work. And let's say I put potassium chromate here. Now potassium chromate, I will be honest with you, is like an orange liquid, but I think you guys get the picture. If I get this K2CrO4, and this one I'm going to make sure you can kind of see what I'm trying to do here at least, potassium chromate. Well, if I mix these two things together, what might happen is this. And again, I'm just going to look really quickly. I'm going to change the camera so you can actually tell what I'm about to do. Again, as you can see right there, I got this. Oop, come on, camera. Let's go. There we go. Got my cool vase. And what you might notice is if I mix a clear solution and another clear solution, voila. And as you can see right here, well, nothing, doesn't look like anything happened, right? It looks like I just poured water into a vase with more water. That's what some of these reactions are going to look like. Okay, if it's aqueous and aqueous and it ends up making two aqueous things, it's going to look like this. Now again, it might be a lighter shade of a color, it might be clear in blue or clear in yellow or clear in red. But if you don't see a solid in here, there's going to be no reaction. You need a solid to form. And that solid is called a precipitate, which is abbreviated PPT. We will talk about that tomorrow, January 25th. Okay, again, I'm going to zoom this guy out for you because, again, I want you to be able to see the screen. I apologize. I don't think you were able to see it, but I'm going to zoom in on that. You need a solid to form. If you don't get a solid to form in a double replacement reaction, well, oops, you're not going to have anything work in the first place. And again, that's not something that any of us want really to happen. Again, I'm just going to adjust really quickly, and we can go from there. I'm just going to back this up a bit. I apologize for the two-part video too, because I know it messes up some of the angles and things. But again, I do want to show you that, again, what it's going to look like when it doesn't work. And I don't want you to get fooled with that. Again, that's double replacement. And the only thing that's left is going to be combustion. And again, you need a solid deformer. It's not going to work. Again, the last one that we need is combustion. And again, a combustion reaction is going to be, for example, C3H8, that's propane, plus O2. Or I could have C4H7OH, again, still a hydrocarbon, plus O2. Or I could have C25H52, again, that's wax, if anyone's curious, like candle wax. All of these are hydrocarbons. CNH, CNH, CNH. You can have some extra, that's fine. And as we already mentioned early in the first part of the video, that's always going to make CO2 and H2O. CO2 and H2O. CO2 and H2O. And that's really all there is to it. There is no really predicting with this one. It's all the same. You just have to be able to recognize where the hydrocarbons are. And that's really everything that we've talked about so far, Unit 5. Again, so far, I'm very happy with how things are going. Again, I've been throwing a lot at you, and that's because I want to prepare you guys for what's coming. And again, this part's the hard part. We are going to continue tomorrow, again, January 25th, with exactly what we did Friday. So again, we're going to keep going with that. We're going to get better at it, and we'll add to it. Again, there will be a quiz this Friday, which is the assembly day. It'll probably be around 18-20 points. Again, I'm going to close the video here. Again, remember where we're kind of going with this. I do plan on maybe doing another summary video, maybe even Thursday this week before the quiz, just to help out a little bit. But again, peace road, bro. Talk to you guys later.